Hi, my name is Jessica Nelson. I'm an undergraduate chemical engineering student at the University of Tennessee in Knoxville, intending to graduate in May 2024. This summer, the summer of 2022, I participated in the Chemical Engineering Research Experience for Undergraduates, or REU program, at the University of Florida. This program allowed me to experience what it would be like to be a graduate student by conducting research full-time. This program also invested in my future by providing professional development seminars once or twice a week, with topics including how to conduct ethical research, unconscious bias in engineering, effective presentation strategies, and more. I worked in Dr. Chuck Hagis's lab with direction from my PhD student mentor, Ruchin Yang. This lab mainly focuses on next-generation semiconductors for energy applications. Specifically, I worked on low-temperature solid-state synthesis methods for chalcogenide perovskites. Solar energy has become a promising source of cheap, abundant, and renewable energy. However, current materials used for solar cells are expensive and have already reached peak efficiency in converting solar radiation into useful energy. This is why chalcogenide perovskites have become an emerging area of research. They display impressive photovoltaic properties, have promising potential for efficiency increases, and they are earth abundant, meaning they are cheap alternatives to current solar cell materials. The problem, however, is that these materials are difficult to make at temperatures below 1000 degrees Celsius. For device application, the synthesis temperature cannot exceed 600 degrees Celsius due to the melting temperature of glass. My research this summer has been focused on developing synthesis method for chalcogenide perovskites around 500 degrees Celsius using powder precursors. To create perovskites, I learned how to safely mix powders in a glove box, program a furnace to heat the glass ampules for a given time and temperature, and perform X-ray powder diffraction analysis to determine the phase created from the synthesis. The main skill that I learned this summer is problem solving. I was responsible for determining how much powder could be put in each ampule as to not overload it. Using relevant literature from the field, I designed procedures for each experiment and determined what ratio of precursors to use. When something went wrong, I had to figure out why it went wrong and how to proceed. And if something actually worked, I still needed to plan the next steps of how to build on the success. Although the main focus of this program is research, I was also able to experience the larger picture of being a graduate student at the University of Florida by exploring all that Florida has to offer. I would like to thank the National Science Foundation for funding this REU, the University of Florida's Department of Chemical Engineering for coordinating this program, and Dr. Hagis and Ruchin Yang for being great mentors to me. I'm so grateful for this program and what I've been able to learn throughout the summer. I will certainly use the knowledge and skills I've gained here in my future career.